We are live. Okay, so today, solving systems of equations. So really, in theory, we have two lines that are going to intersect somewhere, okay? And we could do this by graphing or just by solving. Problem number one says solve, and I think it's easier just to solve it. When I look at problem number one, I'm thinking substitution, because I can see what y is equal to, and I can make a substitution. I'm going to do substitution. I think that is the easiest way for me to do this one, the substitution method, only because I see that y is already solved for. So when I do substitution, I like to write them side by side. Hang in there, Emily. Don't fall asleep on me yet. I'm going to write y equals 3x plus 1, and I'll write the 2x plus 2y equals 18, okay? So when I do the substitution, I like to write them side by side so I have room to work. I can plug one into the other, I can solve it, and then plug it into the other, back into the other, okay? So if I know that y is equal to 3x plus 1, then in the second equation, instead of writing y, we're going to write our 3x plus 1. So I'm going to write my 2x plus 2 times 3x plus 1 equals 18, okay? Again, this is just one method, but to me this is the easiest method, okay? Okay, substitution is the easiest. I could have graphed it, that would have worked also, but I don't know what kind of answer I'm going to get when I graph. So I think this is the easiest for me. So 2x, I'm going to distribute. I'm going to get a 6x plus 2 equals 18. Add those two x's and I'll get a 8x plus 2 equals 18, right? Minus 2, 8x equals 16. Divide by 8, and x is 2. But that's only half the answer, because what I'm really looking for is the point of intersection. So I can say, well, the answer is going to be 2 something, but to get the something, let's do another substitution. Let's take the 2 and plug it right in there for the other x, right? Because x is 2, so let's write 2 in place of x. How's my pacing? Am I okay? Not going too fast? Okay. So I'm going to go y equals 3 times 2 plus 1, right? I'll get a y equals a 6 plus 1, or y is equal to 7. There's my answer. Okay, that's one method. There's three methods: graphing, substitution, and elimination. This one, when I looked at it, I thought the easiest way to do this was just straight by doing substitution. Okay. Number 2, it says graph the system. Okay, so now I actually have to graph it. Okay, so I'm going to get out a piece of graph paper. Okay, hopefully you guys have graph paper. Do you have graph paper? Probably should. Huh? So if I'm going to graph it, let me go ahead and get my XY axis, right? Okay, this is my XY axis. Okay. I'm way ahead of you. Thanks. So on the very first equation, call it equation 1, I'll start at 1. And I'll go up 1 over 2, up 1 over 2, right? Okay, and I'll graph in my line. Right, Connor? There it is. Yeah. Okay. Second equation, let's solve for y first. I'm going to, solve for y. Okay, on the second equation, equation 2, I'm going to solve for y. So I'm going to go minus x, right? I have a y is equal to a minus x minus 2. Okay. If that was a 1 over 1, that'd make it easier for me, right? So I have a slope. And then I can start at negative 2. Go down 1 over 1, down 1 over 1. But I really need to go the other direction because I'm really looking for where they intersect. And I have them intersect right there at the point negative 2, 0. Okay? Okay, can you do that on Wednesday? Sure you can, right? Thumbs up. That should be pretty easy, right? How am I doing? Okay? Not going too fast? Okay, Kenzie, you're showing her how. I like it. It's great. Oh, you can't see. Emily, do you need to sit there? It's okay. All right. You want to borrow my glasses? No. Okay, turn the page. Which is not really turn the page because I didn't copy both sides. Okay, number 3. It says solve. Well, one of the things I see about this problem is that if I had to solve for y first, I'd get fractions. So one thing is like, well, maybe I can do this one by the elimination, which I like to call, instead of elimination, I like to call it the multiplication addition method. That's the way I like to do it. So the whole idea is to get them to be opposites. I can either make the x's opposite and cancel out, or, doesn't really matter, the y's, make the y's cancel. Doesn't really matter. Either way, I got to make them opposite. So when I'm thinking, when I do this, sometimes I'm thinking like a common denominator. Meaning, if I've got a 2 and a 3, I can make them both 6's. Does that make sense? I can make that a 6x, and I can make maybe that a negative 6x. Okay, so what I could do, if I play around with this, I'm thinking, all right, let me grab a red pen so I can show my work. So if I were to multiply this one by 3 and the second equation by negative 2, I think what would happen is I'd wind up with a 6x and a negative 6x. Huh? Okay, so what I want to do, Megan, great question, is I want to make them be completely opposite of each other so when I add them, they cancel. Okay? So if this becomes a 6x and that's a negative 6x, when I add them, they'll be... I could have done this. Okay, watch real closely. I could have multiplied this by 3 and negative 4. And that would have worked also. Right? I just thought the smaller numbers are the way to go, okay? So let me rewrite this, okay? So let's rewrite. So if I rewrite, I'll have a 6x plus a 12y equals a negative 30, right? Negative 6x minus 6y equals 6. Okay, now the whole idea is that the x's are opposites, right? And so now if I add, then the x's will disappear, and I'll be left with y's. I can solve for y's, right? So if I add them, the x's will be gone, eliminate each other. 12y and a negative 6y, or subtract 6y, is a 6y. Negative 30 and 6 is a negative 24. Now what's nice is the x's are gone, which makes it easy to solve for y, right? I can get one of them and go back and get the other. Okay, divide by 6 then, divide by 6. And y is equal to a negative 24. Okay, now that's only half the answer, right? So my answer is a something negative 4, right? So to get this something, let's plug my negative 4 into either the top equation or the bottom, right? Either one. Probably the bottom equation looks a little bit easier, doesn't it? Smaller numbers. So I'm going to plug it into the bottom equation. So I'm going to plug it into this 3x plus 3y equals negative 3. And I'm going to put my negative 4 right there, okay? So let me rewrite this. 3x plus 3 times negative 4 equals negative 3, okay? I'm going to have a 3x minus 12 equals negative 3. How am I doing? Am I doing okay? Pacing's all right? Okay, am I getting a little too fast? Okay, Megan, tell me when you're ready.
I'm good.
Are you good? Okay, plus 12, I've got a 3x equals 9. Divide by 3 and x is 3, okay? So there's my point of intersection, okay? Okay, number 4, last but not least. So I think when I graph this, I'm going to get I'll get some figure. I don't know whether it's going to be a triangle, a quadrilateral, I don't know. I'm going to get some figure. But to do it, let's check it out, okay? See if I can graph this. So, get my graph out. Okay. So you guys remember we said three things. We said I will go slowly. Shh, shh, shh. You will pay attention and not talk. And three, you put cell phones away. So let's go back to number 2. Quiet. And I'll be done before you know it. Okay? Here we go. First of all, let's do the first one in blue. Okay? X is less than or equal to 2. Well, that's an equation right here at 2. If I want less than, I'm going to shade everything to the back of it. Okay? Y is greater than 0. Okay, I'll do that one in orange. 0 is actually the x-axis, right? Y is 0 is really the x-axis, and everything above that would be... Okay, so I got a little bit of double overlapping shading here. Let's see. I'll do Y is less than or equal to 2x plus 4. So I'll go 1, 2, 3, 4. I'll go up 2 over 1, up 2 over 1, 2, 1, 2, 1, right? I'll shade that one in brown. So I'll put that one in. Okay. And I'll shade less than, which is everything below. Okay. And then finally, the last one I want to do, I'll start at 9. Hopefully, like 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. I'll go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. Okay. This one's going to be less than also. So I'll shade that one in. How about red? I haven't done red yet. Okay. So less than. Okay. Now, where do all of them overlap? Okay, I think the reason they all overlap is right in here in green. Okay. Right. Okay. I think I got them all overlap in there. Okay. So what I want to do next is find all the corner points. Okay. So I'm looking for corners. And I've got a corner point at -2, 0. Got a corner point at 2, 0. I've got a corner point at 2, 3. I've got a corner point at 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And if we're going to do a max or min problem like we did on Friday, we're told that our maximum function is p for profit is 4x plus 5y, okay? So let me take my corner points and write them down, okay? So I've got a -2, 0, a 2, 0. Put this back up. Yeah, there's my corners, okay? Okay, I'm going to take my corners, I'm going to plug them in, all right? You got it? Okay, so here's my corners. A 2, 3, and a 1, 6, okay? So let's put that into my profit equation, okay? So, I'm going to go, first of all, P of -2, 0, which means I'm going to plug in -2, and I'll plug in 0 into my profit equation. So I'll have a 4 times a -2 plus a 5 times a 0. Now that answer is -8. That's not a very good profit. It's a bad profit, I would say, huh? So let's do P of 2, 0. So P of 2, 0, plug in 2 and 0 into my equation. I'll have a 4 times 2 plus a 5 times 0, which is a positive. Well, at least I made some money, right? Made $8 instead of -8. That was a bad day there. That's a very bad day. All right. And then I could do a P of a 2, 3, which is going to be a 4 times a 2 plus a 5 times a 3. Let's see, that's 8 plus 15 is 23. Okay, that's much better. That's much better. And finally, we'll do a P of 1, 6, which would be 4 times 1 plus 5 times 6. 4 plus 30 is a 34. That's definitely my best day, huh? So, what would I do? Well, my profit or my maximum is at 1/6 with a value of 34. Okay, how's that for answering that question, huh? Okay, and then homework, it's not that much. 1 to 19 odd. I did give you the odds so you can check your answers, but no work, no credit, right? You've got to show your work, okay? Okay, and I'm going to stop record, and then we got work to do, huh?